we'll get going. So welcome everyone. I'm Harmeet, hosting the Data Engineering Melbourne Meetup. We've been running this, if you're new to this meetup, we've been running this from past 4-5 years now, and we have 4,000 members. So I'll be recording this session, as I mentioned, and it'll be posted to, and it will be shared with the wider audiences as well. Today, welcome. We have already done. Today we have Harsh, who would be sharing their experience and knowledge on OpenMetadata, which is more a tool around discovery of data, metadata management. And once that is done, we'll have a small community marketplace where we'll be giving a chance to everyone in case if they want to share something, like a minute or so, can be for jobs, or if you're looking for job or anything interesting that you would want to share. So without further ado, I'll stop sharing and give it to Harsha to share. Share about metadata management. Over to you, Harsh.
All right, thank you. Can you guys see my screen?
Yeah, all good.
Okay. All right, thanks a lot for inviting us, and thanks a lot for all of you joining and taking part in this session. So my name is Sri Harsha. I work on OpenMetadata. So what we are building is an open standard for metadata, a single place for discovering all your data assets and collaborate with your team and also get your data right? So I'm going to expand on all these aspects as we go through the presentation. And about us, we are a team across, across India, Europe, as well as in US and Bay Area. So we have a lot of expertise. One of the co-founders of OpenMetadata, Suresh Srinivas, is the founding member of Hadoop, and he also co-founded Hortonworks. If you ever worked on Hadoop or anything, you probably heard about that name. And he recently been chief architect at Uber. And about myself, recently I worked at Uber, and I've been currently working at OpenMetadata. I led streaming infrastructure at Uber, and also worked on a lot of data products at Uber. And I'm a Apache Kafka, Apache Storm, PMC, and committer, and contributed to many other Apache open source projects as well. So over the years, we understood a lot of knowledge about the data infra and how the data products are getting built, and what are some of the key aspects that will help users to unlock the value in the data assets, right? So those are the kind of inputs and the experience that got us to motivate us to start the OpenMetadata project initiative. And one of the key aspects that we are actually continue to put ourselves in is to how do we improve the user experience around data, right? So most of the data projects that if you are install any infra projects and everything else, often miss the boat in actually making big data is about how easy it is used for the data scientists or data engineers. So we spent a lot of time last 4 years precisely is to build a lot of no-code editors, build better products like Databook at Uber, a lot of initiatives to help, data products and data engineers to make it easy for them to use. So that's about us and what we have done so far. So in this talk, right, so we are talking about metadata itself. So as I think earlier we were talking about, how data became ubiquitous everywhere in the industry, right? Any company, we are storing a lot of data. The infrastructure itself evolved to make it cheaper, easier to store a lot of data and gain insights from that. And we firmly believe that metadata is the key to unlock what are the important data assets in organizations, and how do you discover those data assets. And as part of OpenMetadata, what we are trying to do here is not just make it's about discovery and it's a governance. And that's what truly like a lot of catalog applications has been. What we are trying to do is it's go beyond that, right? So it's discover, but not just stop there. Collaborate with your teammates, understand how the data is doing, and also quantify, qualify, and improve the data quality itself together with your team. And make the data work for you rather than trying to store lots of data and not get a outcome that you want out of that, right? So that's why we firmly believe that metadata is the key to unlocking the data assets that you have. So kind of state of metadata today, right? So anyone, if you are in this audience, like, if you're trying to set up a catalog or whatnot, each of these tools will come up with their own schemas or, schemas, and as well as some of them might not even have APIs. For example, take a look at any catalog, any proprietary catalog. They are kind of, extracting the metadata, storing it, and their use cases are often around discovery and governance. Then if you want to start, hey, I want to make sure that data that we are producing is of high quality, so that any downstream users, right, any data scientists using that data are building a dashboard, building a report, getting a good quality data asset, people end up building another quality tool, or buying another quality tool that again going to connect to all your data sources, build the metadata in its own format, and start generating its own piece of metadata. For example, quality tool will generate its own metadata such as test and test results, depending on the tables, dashboards, reports that it can gather from all these different components. Similarly, catalog, right? It's grabbing all this metadata and kind of isolating and kind of serving only particular use case, right? Then you have observability compliance. So the problem with that is your metadata itself is not standardized, not centralized. Everyone will have piece of entire picture, but that's actually not collaborating with each other, not integrating well. So you end up having this proliferation of siloed tools that doesn't talk to each other. Example could be if you have a user who is going to visit a data catalog, right? And they're trying to discover, let's say, hey, I want to look at all the tables that related to sales. They went and searched for sales, and now they found the table that they wanted, and they want to check if the quality of the table is good or not. Then they have to jump to quality tool and understand, how that table is doing in the quality tool itself, right? Are they just failing? Is the data that is getting produced is good enough or not? So you get this siloed experience, and the tools itself cannot interchange the metadata they are collecting, right? Because they are also have their own proprietary formats, and it's inconsistent and fragmented. So this is the current state of metadata today, right? Now, where we are going with open metadata is to centralize all of this metadata. So this is at the center of it. And we are taking a schema first. I'll explain what that means. And we are building a very structured API so that metadata that we collect in open metadata can be shareable, right? So all this experience once you have centralized, this tool, once you have this centralized meta store and with an APIs and a schema first approach, all the other applications becomes actually an application on top of your metadata, right? Now you can actually bet and build your metadata in a standard way and build the applications that you want on top of it, or integrate with existing tooling as well. So what is schema? So what is schema first, right? So this is not our first iteration of developing a metadata system. So in our previous lives, we built Apache Atlas at Hortonworks. And then at Uber, we built Databook. If you take a bit, if you're not aware of Apache Atlas, it used to give you a metadata design component as well as a CRUD APIs. So what that metadata design component, right? So example, a company one install Apache Atlas and they have, let's say, Hive as a data lake. And there are a bunch of Hive tables, and they want to start kind of, taking that metadata out of the Hive and putting into Apache Atlas. So one has to actually define how the table should look like by themselves. So company A builds this, and they'll say, table should have name and columns and a bunch of other, fields that they think important. Now, company B wants to use the same set of tools, Apache Atlas and Hive. They go build this. They need to model again the table entity, and none of these things will be the same. Right? Company will be saying, I want 10 fields, another one will be wants 12 fields. So it becomes the standard of metadata is not there at all, right? So everyone is kind of reimagining how the entity should look like, and they're writing their own stuff. And that means any metadata that's getting collected into Apache Atlas is not really shareable, right? So if you're building an open source data quality tool that you like, you cannot bring into Apache Atlas and make it work with different set of these interpretations of entities. So that's why we kind of learned all of these pain points, and we went with JSON schema with a strongly typed approach to table entities. That means we actually take an opinionated view of what the table entity means, and we define in the JSON schema. And we are trying to make that as a standard and a specification that can be used across different tools. So the beauty of JSON schema is it has excellent tooling support. So when we actually define the JSON schema, even within the open metadata, we used across backend APIs, which are written in Java code, our ingestion framework, which is written in Python code, our UI, which is written in React, and our database data and the documentation. All of them are generated in JSON schema. So any change, for example, tomorrow, a community member will say that, hey, I would like to add some extension to table schema, such as I want to store sample data of a table along with the table metadata, right? They can just define that. All of that will reflect across all these tooling, right? So that's a great thing about JSON schema. And a simple example here is it is the user definition of our JSON schema. So you can actually define a commonly used fields like this as a definitions. And you can also provide some constraints, and these will get validated in all these different languages that we talked about, right? So we don't need to kind of create custom validation and everything else. It's clearly defined here itself. Similarly, you can actually reference, for example, UID that we use commonly across all the entities as a unique identity for each, entities that we store. And we only do definition one time and can be referenced multiple times. Similarly, email and Teams, right? And it's machine and human readable. Lastly, you have a required field. This is a backward compatible way of developing and evolving the schema itself. So you can tell by looking at the schema itself, it has these 5 fields. Out of that, ID, name, email, href are kind of required fields, right? So the benefit of this is you're clearly mentioning how we are modeling the entities within a data, like how we modeling table, pipeline, dashboards, machine learning models, whatnot, right? All the assets. And how do we get that into the open metadata? It's also clearly defined by using the JSON schema. So that's a great thing about JSON schema. Next thing is entities and relationships, right? So within the open metadata, so on the left side, all of these are services that you already have in your organizations, companies that you're already working for, right? So in your data infrastructure, you're probably using a data lake service, a data lake and a database service, and you might be using dashboard service such as Superset, Looker, whatnot. You might be having an ETL such as Airflow. All of these are kind of defined within open metadata as a way of connecting to those data services, data sources, rather. So these are a type of service, right? Once you create these services and create an ingestion schedule, we go and crawl all these services and get the data assets, such as tables, reports, dashboards, whatnot, right? All of those data assets and becomes into open metadata as an entity. So we store all of that data. On top of that, each data set should be owned by someone. Any data asset that is not owned is kind of ignored, right? So we want to kind of drive the ownership as well. So a user belongs to a team, and our team can own a data asset and work on that. Similarly, on top of that, we have tags and tag categories. We actually recently built glossary terms. I'll give a demo of that. So the idea here is like, typically in metadata systems, tags is kind of free form flowing, right? So user can come and say that, hey, this is PI, this is something else. The problem with a free-form flowing tags is, user can tag anything without any discipline. So when you come to do some kind of a governance model based on the tags, it's really hard to do that. So that's the reason we actually did a strict definition of tag categories tags. That means, like, once you define these tags, you can only use those tags. As an admin, you can add more tags to it. But as a user, you cannot use the free-form tags. You have to choose the existing tags that is being defined. And tags itself are hierarchical in nature, right? So that's why we define a tag category. Underneath that, there is tags, and you can actually go into more hierarchical nature. Example could be like phone number. Phone number is like a generic type, a generic tag, but a user phone number is completely different from an organization phone number, right? A user phone number is more a privacy-driven approach than an organization phone number. So you should be able to differentiate that. So those are the things that we, help with these tag categories and tags. So this kind of gives you a picture of, what we are doing here. Like services contains a for example, database service contains a database contains a table. So you're actually, when you're ingesting this data, you're building a metadata graph, how they are all interrelated and how they are connected, and what is the relationship that, service content as a data asset is a relationship that we are maintaining. So this way we are actually building a knowledge and metadata graph here. And all these entities, even though we are talking about these are opinionated JSON schemas and everything else, there is a possibility to extend and add your own piece of metadata on top of what we are collecting as well, right? And secondly, once we have the JSON schemas, we also built a RESTful APIs. The motivation behind this is when you're actually querying for metadata, or when you're ingesting, when you're writing metadata, you want to understand the structure clearly. And the API itself, it shouldn't be like a key value pairs where you need to parse and do some complicated code like if else and whatnot, and try to understand this code. Instead, with JSON schema and these REST APIs, you get a strongly typed object back. So when you're actually querying for table, how the table will look like. It will have all the details that are mentioned in schema. Especially if you're actually using the tooling that we provide through the JSON schema, you'll get like in case of Python, you get a class, or a Java, and you get a class marshaled through this APIs. So you know how the table looks like, how the chart looks like, and now the integration of these toolings becomes much more easier, much more standardized, right? And all of these are, we've put a lot of time to document and generate this document and play around with this for anyone who wants to use this in docs mode. Secondly, when we are talking about a schema-based, a metadata that should be shareable, extendable, that can only be possible in an open standard. You cannot do this through a vendor based proprietary format. That's what we drive towards. That's what we are driving this community towards, to be a vendor neutral and open source specification. The main thing that we are talking about is metadata should be solved problem by now, right? So we keep, if you've seen across the data industry itself, there are many projects who are doing this in proprietary as well as few of them in open source, but none of them are actually getting the standardization of around the schemas and APIs right. That is an important thing, to actually establish a standard such that other tools can actually integrate with these APIs and with the schemas, not only ingest the data metadata, but also consume the metadata and generate the metadata of their own, and also can publish into one center place, right? So that's the motivation behind this, and that's one of the reasons what we are trying to do is being vendor neutral and making it an open source project. So this is a bit of an architecture what we are doing, right? So on the left side, so what we have is a pluggable ingestion framework. We open sourced this in almost 7 months back in August of 2021, 0.3 version. Since then, we were able to add 47 connectors. These connectors are, to different data sources, different dashboards that will, connect to them and extract the metadata and publish into OpenMetadata. This is a pluggable framework. It's a simple source processing kind of a workflow methodology, and easy to add any connector you want, and it runs on top of Airflow and similar a schedulers that you're probably already using it. And on the other side, we the APIs and everything is backed by Jetty, Dropwizard, REST APIs, and all of them, ingestion as well as the backend and the UI depends on the JSON schemas to generate the these types and everything else, so that all of these things are in sync to communicate. And we don't want to all the extraction that is happening through is actually using the APIs. So one of the motivation here is, typically when you are building any metadata system in a big companies, it's taken for granted that there are certain infra teams that are providing like a nice infrastructure such as Kafka, where you can pump this data through. But it might not be true for a lot of other companies who, we don't want to drive every simple thing through the Kafka itself. But if that's your choice, you can actually take this not through the APIs, but through the Kafka itself. But to make this architecture solid and simplified, what we established here through the APIs, ingestion also uses that. It's able to read through the APIs, it's able to write through the APIs. Similarly, UI and everything else also depends on the APIs. And we do not want to some of the metadata system actually uses directly writes to their underlying databases and whatnot. We're not going to expose that to the external. Everything is, as we said, schemas and APIs and all of our ecosystem that we are building, tooling and everything is through those mechanisms itself. And it's fairly easy to deploy and kind of manage as well. So we have a less moving parts, and we're getting the integrations done much more easily that way. So that's kind of a rough idea about our architecture. And let me go to our Sandbox. This is a Sandbox that anyone can actually go and log in and kind of play around with it. So when you log in, you are treated with how the data is doing in your kind of company or in your organizations. How many tables you have, how many topics you have, and in between you have activity feed. This is what we are talking about, and kind of putting an extra stress. Data is always been a team game, right? It's not individual who makes up, but it's a collaboration that makes the the data stand out and improvise, right? So I'll go through the details of how, what is this activity feed looks like and what is the necessity behind this. But, important thing here is to simple experience is as soon as you log in, you have a way to kind of go and search for, let's say, for example, I want to search based on sales. We match, columns. In this case, we're matching descriptions and 2-column descriptions, and, there is sales tables itself. Once I go in there, you get the schema of this table. This is a BigQuery table that we sucked in the data from, and you can actually see all the different columns that are there. Similarly, you can actually look at the sample data and the queries that are running against this table. And lastly, there is profiler and data quality that we are integrating. I'll go a little more deeply into that later, lineage and how we extract that and everything else. One of the key aspects that we actually brought in from our experience is the tiering, right? So let me step back and give the examples of tiering. Like at Uber, when we are working there, we have 250K tables, right? So out of 250K tables, when we got a GDPR mandate saying that, hey, we need to kind of annotate all the tables with PI data and kind of enforce the policies around the PI data, all the teams needs to sit for 3 to 6 months, kind of identify all these things. But, and similarly, like when we want to ensure data quality, we cannot really scale for 250K tables, even at Uber cases, because it doesn't make any sense of blindly kind of propagating all these things to all the data assets you have. So we introduced a concept called tiering. So what is tiering is, how do you identify the important tables that are actually driving your business, that are important to your business? So tiering is a way to kind of identify that. These are the description that we actually kind of inspired from Uber and got into OpenMetadata itself. So tier 1 is like, the most critical data assets that is actually driving your business, reports, dashboards, and whatnot. Tier 1 and tier 2, and tier 3 is kind of a group owned. Tier 4 is individual owned. Tier 5 is unused. So we found certain heuristic to kind of tag these data assets, for example, by looking at the query analysis itself, like how many queries are actually going towards certain data assets. Like if there are a lot of queries going to certain data asset, that means it probably is most important data asset. Maybe we should call it as tier 1 or tier 2. Secondly, how many other data assets are actually derived from a table? For example, in this case, it's a fact order. If there are further dimension tables being used based on these fact order tables, that means it might be one of the important tables. Maybe we should tag it as tier 1, tier 2. Similarly, if there are no queries or nobody's actually even issuing any queries against a data asset, like in this case fact order, it could be a tier 5. It's unused. Maybe it's safe to delete. So we went through this kind of process at Uber, and we managed to kind of delete up to 80K tables. And when we done with this process, we realized there is only 1,000 tier 1 tables and around 2,500 tier 2 and tier 3 tables. So essentially 3,500 tables are extremely important for companies, but rest of them are, they are just there by either individuals or the teams, which are not really that useful for the companies. Now, once you identify that, now you can use a better resource management. So then we said, like, we want to make sure all those tier 1, tier 2 table must be high data quality and should be notified, should be owned, should be able to have good documentation. So then your focus is much more narrowed and much more, better to actually get the best out of your data infrastructure itself, right? So That's the tiering aspect of it. So once you have that, you
So
can.
is it, can I ask you a question regarding
Yeah,
this?
go ahead.
Yeah.
Yeah.
So I think this is a great thought. I really love it that, you focus on your main tables. But the question is that you mentioned certain rules about that. So are these rules modifiable, or is it
Yeah.
something which is okay?
Yeah, it's totally up to individual kind of organizations, whatnot, what
Yeah.
makes certain data assets are important to that. So the one that we talked about is kind of made sense for Uber, but might not be the same thing for other organizations. So that's where we have APIs and other things, other
Right.
automation that will help you to kind of determine, hey, these are certain things that makes data assets more important for us. So you can tune it and configure that.
Yeah, this is awesome. And the other question I have is about the sample data that you showed. So the sample data is being captured while the connector is reading the schema
Mhm.
of the data. So how is there a way to take care of the classification, because the data that you may be reading would be of certain classification and should not be viewable by everyone?
Yeah, definitely. So that's what actually we are putting into in this release. We actually have policies and roles. So we are evolving this part where it's just not about. So right now the policies around who can update, who can update the description, update the lineage, owner and tags and other things. Now what we are evolving that to be is like, let's say if the column has PI tag, it could be auto classified, or it could be through manual tagging itself, and only the users who has that PI policy access will be able to view that column even in the sample data, and the rest of them we won't be even serve the data back through the UI, and they won't be able to even retrieve through the APIs itself.
Yeah. Okay. Thanks.
So stepping back into the demo itself, so we have tag categories, as I said, like tags are like hierarchical in nature for us, and
Hey,
that
Harshad,
and these are yes.
we have a question in the chat section.
So one of the questions is, can you show how we can maintain the schema and validation for your data? It's one of the challenging aspects of data quality. Is this tool be able to store schema like schema registry? So yes, let me go to Kafka topics. So we capture again this coming through the Confluent schema registry. We connect to that and we extract the schema and store it here. I'm not sure I understand the question. Maybe if you can unmute and kind of elaborate that.
Yeah. So Shri Harsha, our challenge is where we don't use Kafka in this. So we don't have a Kafka Confluent registry as such. We're trying to explore other things like glue schema registry and stuff. But can just like you're collecting schema registry from Kafka or Confluent itself, is there any APIs where we can we can refer to this as a metadata management or schema metadata management and stuff? Because then
So
the idea is to basically have two source of information for schema across company, or at least in the data platform, and then maintain the validations, have a self-serve environment of extending validations and all sort of things, these things.
Yeah, so I think where we are differentiating here is like in companies there is technical metadata, and then there is like a user metadata, or a centralized metadata repository like OpenMetadata. The differences when you look at that is, for example, in Hive case, there is Hive Metastore, which is actually storing the technical metadata, right? And all your queries and everything will go through that first, and then get a simple plan, then go and execute that plan. Similarly, to be specific to this particular example in schema registry, it's more about in line when consumers or producer are talking to schema registry, it's able to get you different versions of the schema based on the version that it's being queried, and messages, everything. That's more of a technical metadata. So we're not looking at that particular use case right now, but something that we can definitely consider and evolve. What we're trying to do is get the people and the metadata in from various different sources, not just for schema registry, into a single place, such that all of that metadata is in front, and we enable the the people that who are kind of trying to understand and trying to kind of look for data, what they have, what is the schema. So those are the use cases that we are trying to enable. And we also enable data quality, but I'm going to talk about and demo it, what that means in this context.
Thank you so much.
So,
sorry, I think Michael has a question. He's raised his. Michael, do you have a question?
Hi there. Sorry, I'm sorry if I butcher your name, Sri Harsha.
yeah, that's fine.
My question is, so I think you mentioned the tier 1, 2, 3, all that was important for documentation. What else do you use those tiers for? Like, what are they considered? What, can you give me some examples where you would be considering those tiers?
Yeah, so what we are considering tiers is, it's not just about documentation, but there are multiple things that can be driven off of this, right? So automation is one fact. Example could be like tier 1, tier 2 data assets should always be onboarded. Again, these are some of these things depending on the organization itself, how they want to interpret it. But what we did in Uber is tier 1, tier 2 assets are extremely important. So anything that is breaking, similar to a service. For example, we draw parallels to actually a service. Imagine in your company, let's say there's a data infrastructure, and I'm going to draw parallels again from Uber, right? At Uber, we have a bunch of data infra as well as typical load balance and other infra that goes with it. One of the key infrastructure is Kafka. Any message, any request that you're sending through Uber used to flow through Kafka, including payments and whatnot. Everything goes through Kafka in Uber business. So it's a tier 0 service for us. What that means, if the Kafka goes down, that essentially means Uber business is kind of down and users are not getting rides, not getting able to order eats or whatnot. So business itself is down. So people like me will jump on and actually fix that. Now, that's tier 0. Now, there are Hive infrastructure, which is called a tier 1. It's bad because we won't be able to analyze the data, but it's not going to affect the users itself. So that's why it's lower tier little. And so on. There is tier 3 and tier 4 services as well. Like data quality is a tier 3 because, if the platform itself is go down, yes, we're not getting signals of the data quality itself, but it's not actually causing that much of a hindrance to the business itself. So it's all in that regard, right? So now, if you draw parallels to the data, we always say that, hey, this is the new paradigm, right? So data should be maintained should be as code. Data should be treated, as important as a service. Now, how do we enforce that, right? So that means tier 1, tier 2, once we identify those data assets, there should be ownership. Similar to Kafka, there's a team who's maintaining it. There should be, for example, in this case, we are calling factor as tier 1. There should be a team behind it, in this case, data platform, maintaining that fact order, right? They are making sure that all the ETLs that are responsible to generate this table is running on time without any issues. And any users, the second thing is like, how do we redirect the users who are looking for the data into fact order rather than some duplicated table itself? So you want to kind of redirect all the queries to the tier 1, tier 2 tables rather than some copied or unmaintained tables itself, right? So your consumers are the data scientists of this table actually using the high quality data. So as soon as we tier a data asset at tier 1 or tier 2 or a table, we walk through the lineage chain, all the upstream, saying that fact order depends on raw orders, raw users upstream. Those are also should be tier 0 or tier 1 in this case. So they should also be tested. They should also be owned. So all the chain that is responsible for this leaf node should be treated as extremely important because we identified this particular table as the most important thing. So that's kind of a organizational data cultural point of view. Now, second thing is like, again, taking an example of Uber, used to have Presto cluster, right? So pretty much all the queries used to go through the Presto clusters. Initially, we did not know we had this huge cluster, and any query that's coming in used to go through this cluster. We don't know which one is important, which is not important. So we don't, so everyone is kind of fighting for those resources. Now, once you have this tier 1 and tier 2, you can actually say that, hey, these are the extremely important, and making sure that they are getting the utmost resources. Then some are hot query, which is probably important for a user, but not important in the sense of for the organization. you can actually split this, resourcing as well in a much more different scalable way, such that your important data assets are never being clogged, never been fighting for those resources. Does that make sense?
Yeah, fascinating. So yeah, the tier one data should get what you were saying there, the utmost resources, so you can split the resources by the tables, which you haven't really thought about before. That's very interesting. What else? Then, like you mentioned, it kind of sounded like the response time. So obviously, like if tier one data isn't available, like it's going to obviously affect the app itself, and that's terrible. That's lost revenue, etc. That affects the users. Whilst you go down the tiers, and whilst it may affect the data, it's not critical data for the functioning of the application. So maybe your response time, or like it's lower priority, and the response time can be longer. Basically, is what I took out of that. And tier 0 or tier 1, you said the most important was Kafka for Uber. Was there anything else I should have taken out of that?
Yeah, I think one of the most important aspects of when we did this at Uber is the data culture of the Uber, right? So that's it's not easy to quantifiable, like a performance or whatnot. But the important thing is, like, when your organization growing, especially when you have self-serve tools, many data scientists can come and kind of start creating data, bunch of data assets. Suddenly you're looking at, like at Uber, we looked at 250K tables. At that point, governance or any of those initiatives will be really hard to do. As I said earlier, like when GDPR came in, we have sit down like 6 months, everyone actually focusing on that particular initiative, but not asking the question is what actually is the most important data assets. Maybe we should get that first, then maybe look at the other aspects of it. So it's actually putting your efforts, even though when you're collecting a lot of this data, the problem with the collecting a lot of data is you never know what should be deleted, what should not be deleted, and what is the most important thing, and how do you actually turn around the data culture itself within the company, so that we are focusing the right attributes or right important assets, rather than spreading everyone too thin, right? So that's one of the kind of invaluable lessons that we learned from Uber when we implemented the tiering.
Okay, thank you.
So I'll continue to demo. So we talked about ingestions and kind of collecting the metadata itself. So the way we do it here is, like, we have services section. I talked about services in one of the slides. For example, probably this one. Yeah. So we talked about this one. So going back to the demo itself. So when we do add new service, for example, you want to add, let's say, Redshift, you can configure Redshift and start. And you start giving the connection details. We can schedule a workflow right from the UI and start, extracting and crawling that particular service and making available all the data assets in that particular service, like in this case, Redshift and everything else, right? The second thing is we also go, and probably I'll get a better one. So we also go analyze the tables itself and the queries itself, right? So trying to find a good example here. So what we do from there is we do we call it as discovery by association. So we go and process query logs for usage information. Like, for example, in this case, we consider dim shops to be, 82nd percentile among all the other tables within this database based on how many queries it's getting. And also we, find out how many other tables it's getting joined with. So as a user, as a consumer, you're coming here like, hey, what is a frequently used table with this dim shop? So you can actually go and look at the frequently joined table, similarly in the column level as well. The other thing we do here is as well, this is, let's see. This data profiler, right? So whenever the metadata ingestion runs, it's take the snapshot of the profiling. So in this case, customer ID is 100% unique, 100% distinct. Similarly, first name and last name. So as soon as you can start writing tests around these particular things. For example, customer ID in this case, I never want this to be not null. And I can schedule this to be a run, and it creates a test for me, and it will schedule a job for me, and also it will tell me when this test fails, right? So the way, that's extremely important. So again, the aspect of centralized metastore and having all of this experience in a single tool rather than jumping it from one tool to another, you have the entire context in a central, in one single UI, right? So you can have your consumers coming in. For example, hey, as a consumer, I expect first starter to be in this format, and they can write a test, and they can get notified if the test fails, and they can look at the sample data, why it's failing, and everything else. So you get all this experience from the single place itself. And most important thing that we added here is data is a team game. Like for example, I do not know if what tag should be for the last name, right? So I can actually start a thread saying that, hey, in this case, Vivek, can you update the tags? Like similar to like a Slack. But what's missing with the Slack is always been is it's a series of threads that goes away. Like someone asks a question, any person who understands that particular question answers it, they get the answer. But when the question comes again, someone else has to jump in, and if the knowledge is not captured, it's ever flowing, it can be missed, it's never stored. So with this, you can actually start a activity thread, thread around table descriptions, or the tags, or the test failure, and whatnot. So all of this brings in people to actually work together. As a producer of this particular table, I know what this schema is all about, but as a consumer, you might not know. So you can request for description, tell me, like, have a conversations around with your colleagues to actually enrich the metadata. So we are actually extracting the tribal knowledge, which might be missing in Slack, or which might be having conversations one-on-one into a centralized place. Once you have these conversation threads, you can actually pin it, saying that, hey, this is more important knowledge information. I'm going to pin it such that in the future someone can actually refer why we made this change, right? So that's a conversation threads. And lastly, I think there are a bunch of other features that I can explain here, but one of the cool things that we did is like versioning, right? Any change that is happening to your metadata is kept version. Like, for example, in this case, initially we created the schema here through the ingestion bot. Next time I added a bunch of tags. You can see everything here, like a Git history. And we also capture, for example, schema changing. First name is varchar, and it might be changed to something else tomorrow, text or something like that. That might be a backward incompatible change, such as first name itself is deleted. Someone else using that in their downstream dashboard or whatnot, they can get a notification. So all these changes gets captured in here and showed in a really nice format here. And also we send a notification via webhooks. So whenever entity change, you can actually consume this via either integrating into Slack, or your custom automation service itself can get notified saying that, hey, I want whenever entity is created, whenever there is an entity is updated, whenever entity is deleted. So any changes that is happening to your metadata can be triggered through the webhooks, through the Slack for notifications. And typical, again, as a consumer, you can follow what interests you, so you can get updates here. So this is the all activity that is happening across the organization. And I'm just interested in my own data, whatever the data that I own, wherever I'm following. If someone actually mentioned me to do something about, in this case, I've been asked, like, hey, can you take a look at this particular tags or whatnot? So all of that can be managed through in this place, in a simple place. So that's kind of roughly concludes. I mean, there are a lot more to do, but I will probably take questions from you guys and kind of answer anything interesting here.
Harsha, I have a question about like what part of all this can be done through IAC infrastructure as a code, or maybe Terraform or something.
I think you broke up last. Can you repeat the question?
Oh, sorry. Yeah, can like creating the connection and a lot of other things, like how do you manage the version control of the code, like the connections that you're creating? So is it possible to do all these things to IAC infrastructure as a code? Is there a Terraform plugin?
Yeah. So 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 there is multiple ways to schedule the metadata ingestion itself. So you could actually write your own Airflow. So you can we documented everything here in the connectors. As I said, like we have 47, one of the fastest growing, one of the highest number of connectors that we have, as our motivation is to bring all the metadata into center place. For example, let's say BigQuery, right? So you can actually build this as your own configuration file and deploy into Airflow or any other scheduling services you are using as a code. So and we wanted to make it easier for anyone who wants to try out or wants to kind of deploy without using any code. They can actually use the UI as well, but it's not restricted to that. You can actually maintain all of this through the code as well.
Okay, that's good. So is there like, I mean, is it Python or Terraform, or is there any like, or it works with everything?
So yeah, ingestion works with Terraform. It's a Python-based framework. You could run independently. You could use a scheduler such as Airflow. We keep repeating Airflow because it's one of the popular ones, but there are a bunch of other Python-based schedulers as well. It will work in that, like a prefect or whatnot.
Okay.
And the service itself is you can deploy using as a bare metal or Kubernetes. We have Helm charts. We pretty much ran on AWS, GCP, so far Azure, all the popular cloud services, as well as self-managed Kubernetes as well. We have users who went into production in both cases. Some of them are using cloud, and some of them are using their own native KX to install, and some of them are actually deploying it through the bare metal as well.
Yeah. Any questions from anyone else? Yeah, while everyone else is thinking, or I have another question. Who are your, like, are there any competitors like in open source who are doing similar things, or
yeah,
not?
I mean, there are, like, for example, the older model data systems are Apache Atlas and everything else. I think it's again built by our teams previously, so we learn a lot of those things and kind of improving it. There are few, but other options available as well. We believe the combination of schemas and APIs are the most powerful. And also, we're putting a lot of effort into the usability of the product itself. And why we are bringing the collaboration aspects into the data is also a thing to consider, especially around the schemas and APIs, right? So, imagine a situation where, for example, in this case, let me go to the data quality in this case, right? So I don't know if you're familiar with Great Expectations, anyone in the call, but it is one of the popular tools to build the data quality, right? So what we have done here is, again, Great Expectations is a Python library, and they have Python methods to kind of similar to, I think you can kind of draw parallels to what we're doing here. Column values to be not null is one of the Great Expectation method. So what we have done is, working with the community, we actually convert this into a JSON schema, right? And we're generating these JSON schemas, and we are building our own data quality library. But if you have your own data quality, like Great Expectations, we do integration as well, right? Because of the APIs and schemas, we can actually adapt whatever Great Expectation is generating and publish those results into the open metadata. So if you already have a bunch of tests running in, you can just hook up open metadata client, and it will take that whatever Great Expectation is running along with the results and the test, it will publish here, and we will show the details in a time series fashion. So that's the power of schemas and the APIs. It's that the metadata itself not locked in this in this one place and without any structure or anything. We want this to be a solved problem. We want this tool to be integrated across all the tools, so that you're not necessarily duplicating this metadata, you're not actually siloing your tools. So all of this can be shareable and everything else. So that's one of the founding principles behind open metadata. And we firmly believe that it's one of the unique offerings of what we are doing compared to whatever the competition is doing, and why we are kind of better in that aspect.
Thanks. Do we have more questions?
So I think key differentiator, and just to simplicity, again, we talked about schema first approach, robust architecture. Again, we built highly scalable system. Myself and Project Kafka committer, Suresh worked on from the from the ground up of Hadoop itself. So we understand not throwing distributed system for in unnecessary cases. That's one of the reasons we try to keep less moving parts here. And if you want to introduce a Kafka-like system in between, it is possible. But unless you have like a crazy amount of scale, it's not needed. And we want to go beyond catalog to collaboration, right? So catalog's always been a passive kind of, hey, here is your metadata. You can update description, kind of tags. You can search, but beyond that, there is not much used to happen. So you want to go beyond that and kind of bring the people in, as well as collaboration. Now, lastly, the automation. Now, one of the aspects that we are talking about is, hey, what this metadata changes, we are generating an event. Take an example of, let's say, lifecycle policies, right? Let's say this table is tagged with PII sensitive. And in your organization, that anything that is tagged as PII sensitive should be deleted every 3 months, right? As soon as something like this happens, you can actually invoke an automation saying that, hey, raw customer is now tagged as a PII sensitive. We need to set up a policy such that it gets garbage collected every 3 months. That's the automation. So those are the things we want to get towards, and that's the next level of roadmap that we have. So bots for abstracting, automating, and mundane tasks like quality, data deletion, tag propagation, and allowing users to write their own bots as well. And hopefully, what we showed kind of showcased our efforts into the UX and usability as well. So yeah, that's kind of a differentiator. And lastly, sorry to interrupt, but lastly, we are available on Slack. So if this something interests you and you want to try out whatnot, POC, feel free to jump into Slack. We are very active. We want to help everyone out and get them started on OpenMetadata, and we put a lot of effort on the docs as well. Hopefully that shows you can visit it and you should be able to self-serve from there. But in case something is not working as per your expectations, feel free to get into Slack. We'll be available 24/7 there as well. Yeah. So
Cool. This is awesome. Yeah, I liked it, and I hope the audiences also liked it. Yeah, if you have any questions, folks, feel free to put in the chat or maybe unmute. Or Harsha, is there a way we audiences can reach out to you? Oh, I think they can. Yeah.
So Slack is the best option for us. So it's just not me. The entire community is there. Community is also growing, so you get to see. So we are community general, our support channels, and ask a bunch of questions there. Just drop in and say hi. I'll be welcome as well.
Sounds great. Cool. Yeah, thank you so much. It was really, really awesome, and yeah, hopefully everyone liked it. So now we have if there's anything if you're looking for employees for your organization, or you yourself are looking for a job, or if you have anything to share, you can share it with the audiences. If anyone wants to share anything, if you're looking for people to contribute in your open source, or if you want people to join your conferences, anything. Is there anyone who has anything to share?
I just wanted to ask, how often do you catch up, by the way, Harmeet?
Yeah, we run like every month, last Thursday of every month.
Last Thursday of every month. And how do you get the details, make sure you're subscribed to receive details?
Yeah, you can join the Meetup, like the channel, and then you will be able to get the notifications. Was that your question, Michael?
Yeah. Okay, so via Meetup. Okay, cool.
Yeah. So if you join the Meetup whenever we publish an event, and soon, maybe in May, we'll see if we can go to in person and stream as well. We'll see how things open up. Cool. So maybe, thanks to the audiences, thanks to Harsha and Vivek for sharing the great insights, and thanks to ThoughtWorks as well, because they're paying for the meetup. But Harsha and Vivek, it was really, really awesome, and we loved the presentation, and hopefully everyone liked it.
Thanks a lot for inviting us.
Yeah, and if for rest of the folks, if there's anything else you would want to hear about, let us know. We can arrange, we will try to arrange those talks, or if you yourself want to, share your experiences or insights on working on anything data engineering, we're happy to host you as well. You can reach out to me or Tim. These are our IDs, or you can directly ping on us on the Meetup channel as well. So that's all for today, and we'll have our next meetup on Thursday, 28th. We'll share the details about the talk as soon as we finalize one. Thanks, everyone. Thanks for joining in today.
Thank you.
Enjoy your evening. See ya. Bye.
Thank you.